We are now starting the next section of probability. None of you will have seen this. Most of it is going to be completely new to all of you. Okay, so in maths, a set is a collection of items or numbers. So we're talking about a set. Now, similar to school, where classes are often called sets, in a school, a set is a collection of students. Now, they might be separated because of ability. So you might have set 1, set 2, set 3. Also, you think about your school might be separated into year groups. So that's something that defines them. So a set is a collection that have something specific in common. First thing I need to do is introduce some new notation, so symbols, that mathematicians use when defining sets. Now this is set A. Now you know it's set A because we've got A equals. We also have these curly brackets around the numbers. So set A is made up of numbers 1, 2, 3, 4 and 5, and they are always enclosed by these curly brackets. So the universal set is the whole thing. So what everything else comes from. Now you will notice in exams, especially doing higher tier, that they want to use the correct notation and terminology. So the letter that we use to describe the universal set is actually a Greek letter, and it's called Xi. Now it's the 14th letter of the Greek alphabet, and it looks like this. So if you ever see this symbol, it means the universal set. Now the universal set can then be split into subsets. For example, if we had that the universal set, now I know it's universal set because it's used Xi, was the whole school in curly brackets, then a subset of that might be year 10. So a subset A is year 10 with my curly brackets around it. Another subset might be girls. Another example might be that the universal set is the numbers between 1 and 8. And a subset A of that might be the numbers 2, 4, 6 and 8. And another subset B might be the numbers 1, 3 and 8, not necessarily having anything in common. Now you also might have a third set. There's no strict rules on how many you have to have. So set C might be the numbers 1, 4, 6, 8, all enclosed in curly brackets. Now you have seen Venn diagrams before, and you've used them to sort and classify sets. We definitely use them as part of our factors and primes and highest common factor, lowest common multiple, I think in Unit 1, which made that a lot easier. So Venn diagrams make this topic a lot easier as well. So for example, we've got set A and set B containing these numbers, and we want to put them in a Venn diagram. So we can start off by putting all of the numbers from A in set A and all of the numbers from set B in B. Hopefully you'll see we've got a bit of an issue because the numbers 3, 6 are in both circles. So you already know that the intersection of A and B are where these numbers need to go. So we need to move 3 and 6 into there and then rub them out in their individual circles. Pause the video and have a go at putting these two sets, X and Z, into a Venn diagram. Once you've had a go, press play and see the solution to check you're correct. So now we're going to do the same thing, but we're going to involve the universal set. So we know that the universal set is the numbers 1 to 15, because we've got the letter Xi to tell us it's the universal set. And then set A are the prime numbers and F are the multiples of 3. Now, prime numbers obviously go to infinity, so we are only concerned about the prime numbers that are in the universal set. And the same with the multiples of 3. So we only want the multiples of 3 that are in the universal set. So the prime numbers are 2, 3, 5, 7, 11 and 13. So we can write set A equals, with our curly brackets, these numbers. Next we're looking at our multiples of 3. So they are 3, 6, 9, 12 and 15. And again, we can write set F equals, and these numbers in a curly bracket. Now you just need to do the same as before and put them into a Venn diagram. So first of all, we've got a common number in both, which is 3. So that's going to go in our intersection. All of the numbers left over that I've highlighted there in blue need to go into the A circle. And all of the ones in yellow need to go into the F circle. Now we need to look back at our universal set and cross off all of the numbers we've already put into our Venn diagram. So we've already done 2, 3, 5, 6, 7, 9, 11, 12, 13 and 15. So we have left, out of the universal set, some numbers. So we've got 1, 4, 8, 10 and 14. These numbers need to go round the outside of your Venn diagram. So that's why your Venn diagram always needs to have a rectangle around it, so that we've got our extra numbers from the universal set. Okay, same thing as before, pause the video and have a go at this example question with the universal set. For the last example for this video, we're going to involve the universal set, but we're also now going to have 3 subsets of that. So we've now got A, B and C. First thing you need to do, as before, is find out your subsets A, B and C. So A are the prime numbers that are in the universal set. So we've got 2, 3, 5, 7, 11, 13, 17 and 19. Next we've got B, which is the multiples of 3, so 3, 6, 9, 12, 15 and 18. And finally we've got our subset C, which are our odd numbers, so 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. Now we're going to have a Venn diagram with 3 circles for A, B and C. First we're going to look for the middle section. So we're looking if there is a number that is in all 3 sets, so in A, B and C, and there is, the number 3. So we can put number 3 into the centre of our Venn diagram. I would then make sure as you go, so you don't make any mistakes, to cross it off in both the universal set and where you've written your subsets A, B and C. Next we're going to look at this section here, which is the crossover between A and B. So are there any numbers between A and B that are in the same? Now there is one number, which is 3, but we've already dealt with it. So we're going to move on. We're going to look at the crossover between A and C. Now there's quite a lot here that do cross over and are in both of the sets. So we've got 5, 7, 11, 13 and 17 and 19, and also the 3 that we've already used. So those numbers can all go into that section on the left hand side, the crossover between A and C. Again, remembering after you filled it in to cross off those numbers in the universal set and also in your subsets. Next, we're going to look at the crossover between B and C. So are there any numbers that are in both B and C? And there are two, 9 and 15. So both of those numbers can now go into that section, and then remembering to cross those off in the universal and your subsets. Now we can look at what's left in set A, and we have only got one number, which is the number 2. We're now going to do the same for B, so we've got the numbers 6, 12 and 18. And then finally the same for C, and we've got the number 1. Same as before, we now need to look at our universal set and see if there's any numbers that didn't fit into the circles A, B and C. And we have got a few, so we've got the number 4, 8, 10, 14, 16 and 20. So all of these need to go on the outside of your circles, but still enclosed by the rectangle. Okay, final question I want you to do on this video. Have a go at this in your maths books and press play to see the solution to check you're correct.